Hello, this is Mr. Collier, and today we're reviewing the Pythagorean Theorem. So recall that the Pythagorean Theorem states that in a right-angled triangle, this only works for a right-angled triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Okay, the hypotenuse is always opposite the right angle. Okay, there's the hypotenuse. Always opposite the right angle, and the hypotenuse squared equals the sum of the squares of the other two sides. Okay, here's another representation of it. This is a 3, 4, 5 triangle. The hypotenuse is 5, and you can see the square here is 25, and that equals the sum of 9 and 16. So we're going to use the Pythagorean theorem to solve some problems now to figure out some missing side lengths in some triangles. So we look at this first triangle. It's a right angle triangle, so we can use Pythagorean theorem. Here's the hypotenuse, okay, or we call it C in the formula sometimes. So let's call it C. You can even call it H if you want. C squared equals the sum of the squares of the other two sides. So it's, let's call that 6 squared and 8 squared. So working that out, we get C squared equals 36 plus 64. C squared equals 100, so C equals the square root of 100, which equals 10. So this missing side length is 10. Now this triangle, here's the right angle, and opposite the right angle is 25. That's the hypotenuse right there. Okay, so we can call these two sides A and B, doesn't matter which one's which, and this one's C, and our formula becomes 25 squared equals 7 squared plus b squared. Okay, so 25 squared is 625, 7 squared is 49, and we subtract 49 from both sides of the equation. We're solving for b, the missing side length, and that gives us 586, I believe, equals b squared. So b equals the square root of 586. Alright, so let's use the calculator for that one. On this calculator, square root's right there. I gotta press shift and this button to get square root. Oops, let me clear that. So shift, square root, and 586 equals. So we get approximately, so we have to round it, it's 24.2. Okay, so this is the exact answer. If it's a non-calculator test, you can just write the exact answer, but here's the approximate answer that you can get with your calculator and rounding. Okay, next couple of examples, we do the same thing. We identify the hypotenuse. Let's call it C, and these are the A and the B. And we have 6 squared plus 15 squared equals C squared. And you can actually do this if you got a calculator. You can just type in all this on your calculator. You don't need to do the intermediate steps. So we get square root of, oops, let me clear that again. Square root of 6 squared plus 15 squared. And we get 16 point, this rounds up to 2. This is approximately 16.2. Okay, in this example here, the hypotenuse is 52. So we can do 52 squared equals 24 squared, and let's call that x, equals x squared. Okay, so we can subtract 24 squared from both sides of the equation. And x equals square root of 52 squared minus 24 squared. So we can do that on our calculator. Square root 52 squared minus 24 squared, and we get 46.1.